All right, here we go. Section 1.3, data collection and experimental design. So we're going to be talking about how do the studies or the experiments, how are all those actually put together, and what's the whole process of actually completing a statistical study or experiment. All right, and so hopefully you'll have an appreciation of someone who does this at your job or someone who does this for an organization, and what all goes into it. All right, here we go. Designing a statistical study, identify the variables of interest in the population of the study. So, what are you actually trying to, do? What are you looking at? Develop a plan, a detailed plan for collecting the data. Collect the data. Describe the data using descriptive statistics. Using descriptive techniques. We'll look at that in the next chapter. Interpret the data and make decisions about the population using inferential statistics. So we're looking at, okay, we have these samples. What can we conclude about a population based on these samples? That's pretty much what statistics does. All right. And then identify any possible errors if applicable. All right. So first, we talk about types of statistical studies. The first type is observational. Observational. All right, an observational study. Research does not influence responses, but observes and measures responses. So there's nothing introduced, which is the researcher just go in and do what needs to be done and then collect the data. All right. Next is experimental study. So with this one, the researcher applies a treatment. So something is introduced before observing the responses. So they want to know, it's like a cause and effect, or cause and reaction, what happens. All right. So for this, treatment is applied to both a part of the population. Treatment is applied to a part of the population and label the treatment group. Treatment not applied to the other part of the population is labeled the control group. The control group also may be given a placebo or a fake treatment. So you're going to have your group or your study. Something's going to be introduced, and then everybody's going to get something. But then you look to see what the reaction is for some people getting something and some people are not. All right, so that's a placebo, the fake treatment. All right, determine whether each study is an observational study or an experiment. I'll let you pause so you can read it. Researchers studied the effect of vitamin D3 supplementation among patients with a viral infection. To perform the study, researchers give 2,700 U.S. adults either a daily vitamin D3 supplement or a placebo for 4 weeks. All right, thank you. Pause. You've seen it. You've read it. This is experimental. So something is introduced into the environment. So a supplement is introduced into the environment. I'll say that, into the environment. So something is changed. Something is added. Environment is just basically what space that what they're in. All right, number two. A researcher conducts a study to determine how confident Americans are in the U.S. economy. To perform a study, researchers call 1,019 U.S. adults and ask them to rate current U.S. economic conditions and whether the U.S. economy is getting better or worse. I hope you paused or just reading along. All right, good. Observational. So nothing was introduced. They just literally just called and asked a question. So this is observational. They don't really ask you to give the reason, I don't think, but I'm just giving it to you because we're learning it now. So a call was conducted, nothing introduced, nothing new introduced. So pretty much they didn't want a reaction. They didn't want to cause a reaction. They just wanted to know what was happening right then. Okay. Data collection. Data collection. There's two main types of data collection versus simulation. This is the use of math or physical model to reproduce the conditions of a situation or process. So, an reenactment or replay of a situation or scene. A good example of this would be the car crashes. They always want to know what is the impact, because people want to know how safe is your vehicle. But in order to prove that, we don't want to put anybody actual body in there, right? So they put in uh, a model of a human, and then they put it in a car and see what the impact is. All right, that's simulation. And then the second, which is more commonly done, is a survey, an investigation of one or more characteristics of a population. So commonly completed by interview, internet, phone, or mail. And then the book doesn't say this, but even apps. Those apps that you use, those are actually surveys. They're actually looking at what are you doing, what time of the day are you going certain places, what coupons or what discounts give them the most traction. So they're actually collecting data off of you when you use those apps. All right, not bad. Just they're collecting data. All right, experimental design. There are three keys to carefully design and experimental design to ensure unbiased results. So unbiased means we have some results that are not swayed or trying to point you in the right direction. All right. Versus control. We're going to identify confounding variables, any outside variables that influence the experiment or study. So, for example, a coffee shop owner experiments by remodeling a shop at the same time a shopping mall has a grand opening. So I don't know if it was because more people were going to the mall because it's the beginning of the school year, or is it because of the coffee shop remodeling? Which one had the increase of sales? Don't know. Those are outside variables that may have affected the data collection. Okay. Blinding techniques are when subjects don't know who gets the treatment, but the researcher knows. Double blinding is when the subjects nor the researcher knows who gets the treatment. So when we're talking about control, we're looking at an aspect of also, um, do the subjects know who are getting the drugs, the real drugs, and or the real treatment or fake treatment? Does the researcher know? Does anyone know? So that can be a factor in getting good data. I'll say that good results. Who knows what? Yeah. And then the structure of the questions in a survey must be controlled as well. So let's think about this one. How do you feel about chocolate versus why do you think chocolate is bad for you? Let's think about what that's trying to say. Mm-hmm. Yep. So saying this is stating they really want your opinion. How do you feel about chocolate versus why do you think chocolate is bad for you? This is, even if you didn't have a clue what chocolate was, this is trying to sway you that chocolate is bad. We know it's not bad, but for a question to have that kind of tone to it, they're looking for something specific. So that's how you can actually get some data that's misinterpreted, I'll say. All right. Then the second type of second things to consider with experimental design is randomization. So randomization, randomly assigning subjects to different treatment groups. Um, so we're looking at how do we actually say it's random. So random is random, but we can't have it too random because naturally we will gravitate towards a pattern. So random is really not random. All right. So let's look at the different types of randomization. So completely randomized design, subjects are assigned through random selection. So this is very, like I said, it's very, not, I won't say unreliable, but it's a little sketchy, I'll say, because randomly choosing people, you don't know if you're getting the right people for what you need. If that makes sense. All right. So this is subjects are assigned through random selection. There is no kind of guarantee that you're getting what you're supposed to be getting. Randomized block design, subjects are assigned to blocks. Then subjects are assigned to control group and treatment group. So it's like you're taking all of your subjects, you're breaking them up into different categories and making sure that you have a representation of each category. All right, so you don't want everyone in this category or this block to be treatment, everyone in this block to be control. Because something, something could affect one block other than rather than the other. So you want to make sure you have a mix of your different blocks. All right, matched pairs design. This matches subjects who are similar. Matches subjects who are similar receive one treatment while other receives a different treatment. So this matches subjects with a similar characteristic, with one with the treatment, one with not a treatment. So kind of like this. So this is a similar characteristic, and match means we're going to match them up. Similar characteristic, we're going to match them up. All right, just make sure we have one of each. So again, randomization is not really random because if you do it too random, you won't get the results that you need. All right, now lastly, replication. This is the repetition of an experiment using a large group of subjects. So, giving the same vaccine to 10,000 people, that's doing the same thing over and over and over and over again to make sure you have a good number, and then you're doing the same thing over and over again to make sure everything is controlled, pretty much. All right. So, note here, this is one of our terms. If you're going to write down your symbols or write something somewhere that you can keep up all your symbols in this course or definitions that you may need to know. This is the first one. Sample size. Sample size. So sample size is the number of subjects. Is very important in experimental designs. So n is equal to sample size. How many do you have in your sample? Because you want to make sure you have enough to say that you've represented um, a certain amount of your population. Meaning, if I just ask you individually how this class is going, can I really just rely on your answer to speak for the whole entire class? So, n equals sample size 1, is that going to be enough? No. So, in this course, we're going to talk about sample size. How do you actually calculate sample size? How do you know when you have enough sample size? We're going to be getting into that in this course. So, your first symbol is a lowercase n. It does matter if it's lower or upper. Lowercase n equals sample size. All right. Last section, section for this section. That's part for the section. Sampling techniques. So two sampling techniques that we see is one is the census. This is the count or measure of an entire population. So census deals with population. Sampling is a count or measure of a part of a population. So this is entire population, and this is a sample. Entire population, sample. Because of the use of samples, sampling error is evident. Sampling error is the difference between the results of a sample and the results of the population. So what did you get in your sample versus what is the population? That little bit of room, that's your sampling error. Not bad, it's just that we have to calculate or just remember that we are going to have some type of error because we're using sample and not population. All right, types of sampling techniques. First, you have your random sample. This is every subject as an individual has an equal chance of being selected from a population. So every person as an individual. So, for example, once a week, the organization uses a computer program to choose a client for the firm to provide lunch for as a reward for their business. So that one person, that one computer, I mean, that one client is chosen from a computer program, just one, and they're chosen, and that's what they're pulled in as an individual for the experiment or for that technique. All right. Now, random sample we don't do too often, but it's just this is the basis of or the lowest level of sampling techniques. All right, so you won't see this too often. Now you're going to start seeing these other ones. These are the ones you'll be testing on. Simple random sample. Simple random sample. So random, it was just one person being chosen for the experiment. Now, with simple random, all samples of the same size have an equal chance of being chosen. So, all samples, that means that the different types of samples that we can make, they can equally be taken. So, random, which is you as a person, you can be chosen. But simple random sample means we're talking about all of the sample can be chosen. So, all the samples of the same sample size can be chosen. All right, so we're just taking any sample. In any kind of way that you can rearrange it, that's the simple random we're talking about. Any kind of way that you can rearrange your samples, all those can equally be chosen. All right, a common technique is to assign numbers and choose numbers randomly. Choosing different groups have an equal chance of being selected from the population. So it's not you as an individual or you as a person you're looking. You could be in any sample, and any sample can be chosen. So any group. So we're talking about choosing different groups now with simple random. All right. Let's look at an example of this. There are 731 students currently enrolled in statistics at your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. So normally when you're choosing simple random samples, things are already labeled. If they're not labeled, we can label them using the random numbers table. So already labeled may mean phone numbers, student ID numbers, house numbers, any kind of way that you're already labeled. You can't just be labeled. We can pick it. If not, then we'll give numbers out and then choose randomly. So we'll label them and then choose randomly. All right, so we have 731 students, right? Sample of 8, so that means n is equal to 8. All right, sample size n is equal to 8. We have 731 students and we need to label them. They're not labeled, unfortunately, so we need to label them. How do you label? You look at the number of digits of your largest sample um, sample that we're choosing from. I guess. Well, I guess is considered our population if we're going to choose 8. All right, so this is the population, 731 students. I need to label them. To label them, let's look at the highest number. That's 731. So I need to label them 1 through 731, right? I can't name the first number or number the first number or first person just a number 1. The digits have to equal. If there's 3 digits here, my first number must also have 3 digits. I'm going to say that one more time so you don't have to rewind it. The last person has 731 as their number. The first person has to have those same number of digits. I'm going to call them number 1, but in order to randomly use this chart, all of them have to have the same digits. So if I had the 1,000 students, then it'd be 0001 to 1000. The digits have to match. If it was 49 students, it would be 01 to 49. Okay, so the digits have to match, and you'll see why. Let's look. So we want to choose 8 students, right? We can choose to start anywhere, but for grading purposes, we have to start in the same spot. So I don't know if you understand. So you start anywhere on the table, but for grading purposes for the course, we will start in the second column, third row. So this is the second column, third row. So we're going to start here. Pause. You could have started here, could have started here, could have started here, you could start anywhere. But to make sure that everybody's good, we're going to start at this specific spot. Okay? All right, let's go. So we're going to choose every 3 digits. That's why we have to make this even. Every 3 digits, we're going to take those numbers and we're going to pull that student. So starting here, 719. That is student number 1. 719. Highest number, 731. Start it right here. Now my next student is 123662. That's my next student. All right, next student, 123 is 738. Actually, I can't count that one. Think about why. I think you got it. So I don't have a student 738. When I try to go pull that student, I don't have it because they're outside, which means I don't have that student number. So guess what? I'm going to just keep moving. I'm going to choose that next student, 650. I couldn't pull 738, but I can pull 650. Next student, 004. So again, 004, I'm not going to call them student number 004. I'm just going to call them student 4 because they're not going to know what in the world I'm talking about. I know because I'm running an experiment, but they won't know. So 004 is actually student number 4. Same thing for the next. 123. That's student 53. This is how we keep everything even, how we keep everything fair. So if I just do three digits, then I'm missing every one from 0 to 99. So I have to keep it fair. Next, 1, 2, 3 digits is 589. Next is 403 digits. 1, 2, 3, 403. Let me count to see how many this is. 1, 2, 3, 4, 5, 6, 7. Okay, it was 8, but I had to skip over that one, so I got to pick one more. So I did pick 8. One of them did not fare out, so I got to pick the next one. 1, 2, 3. All right, if you need to run back over that one more time, it's a good time to pause and go back. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. Normally, again, your subjects are labeled. This time they were not, so I had to label them and then pick the numbers. On your homework, they could use this and just, pick numbers. That actually could give you a list of students tied to those numbers, and you have to give the actual students' names so they don't know the numbers. So just be careful with this problem in your homework, okay? They can actually ask you what numbers are they, or they can assign numbers to the students and you have to let them know if they've been chosen. All right. Next is stratified. So with simple random, we labeled the students and then we chose them, or they were already labeled and we chose them as a group. With stratified, a sample that is drawn from several separate subsets of a population. So what is done here is they take the population or the sample or the actual population, and they break the sample into something with similar characteristics. All right. So, for example, subjects are, for clarification, subjects are divided into groups, sometimes called strata, that have similar characteristics. Then a subject is chosen from each subset. So that means they're breaking the sample up and making sure they have a little bit of each from every different characteristic. For instance, you divide the student population with respect to majors and randomly select and question some students in each major. All right, so everybody's divided up by major, and then they choose a few people from each major and make their stratified sample. The next sample is the one people get mixed up with stratified, which is cluster. For the cluster sample, a sample where the population is naturally arranged in subgroups and the entire subgroup is chosen. So normally with cluster, they're already in subgroups. Doesn't have to be, but sometimes they are. This is not a requirement. Sometimes you do have to um, break up the group yourself. Most of the time, they're naturally. You may have to break it up yourself. If you do, that's fine. But this time, you're not taking one of each. You're taking an entire group, the whole group, the whole thing. I think of this like turtle clusters. When it's one of my favorite candies. It's like the caramel and the nuts are in there and the chocolate's on the outside. And instead of just picking up all the peanuts or picking up all the caramel, take the whole thing, the whole entire candy. So example of that is you need samples of Cumberland County residents. So each home and the zip code is chosen. So zip codes are already broken up naturally, and you choose the whole entire zip code. So each home in the zip code, so to everybody, not a number of them, but everybody was chosen. All right. And last, a systematic, excuse me, not last, but next, systematic sample. Last page of the notes. Systematic sample, a sample where the members are ordered, then selected according to a random starting point and a fixed periodic interval. For example, students are numbered 1 through 400. Starting at 5, every 50th is chosen. So it's a pattern to it pretty much. You don't have to start at 1. You start somewhere and then there's a pattern after that. So that means student numbers chosen are 5. We started there. 55, 105, 155, 205, all the way to 355. And that's how that was chosen. Systematic. There's a system to it. Convenient sample is the last one. Members are chosen based on who is easiest to get to. So if you want to conduct a survey of students taking a science class, you select students who are in your biology class. Well, isn't that convenient? So you're just going to get those students because you know they're in a science class and you need a study showing something with science. So you go to your biology class. Less work, easy peasy. All right. So for our examples, we're going to look at how some of those may or may not have bias or not. So in your homework, these questions do include do you see any bias or do you not see any bias? Don't wreck your brain too much on those parts. I just want to make sure you understand how the techniques are sampled. Okay. The bias, they have their views, you may have your views. So just make sure you know how to identify the sample technique. The potential bias, you know, it depends on the person. So don't don't think too much about that part. All right. All right. Questioning university students as they leave a college cafeteria. A researcher asked 342 students about their eating habits. So let me write them all out somewhere that you may see them. We had simple, random. We had stratified, cluster, systematic, and then convenience. Those were our options. Make sure I got them all. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6. Okay. Oh, 5. Excuse me. 5. All right. What you got? Okay. Good. This is convenience. Normally, I don't go over these with you, but I just want to make sure you understand all of these. All right. So convenience because simple, random, nobody was labeled. Stratified, nobody. The group wasn't broken up into anything, and we didn't take one of each. Clustered, nothing was broken up or already divided, and we took the whole group. Systematic, I didn't see a pattern. Convenience, there was no thought in getting this answer. All right. So what about bias? We'll do bias for maybe one or two of these. Think about it. I won't write anything down. Just kind of think about it. You're only getting a certain group of students. Eating habits of those college students in the cafeteria, they probably all have the same thoughts. What about college students who live off campus? Are any represented here? Nope. Um, what about students who don't like the cafeteria? They're not represented, right? So this is why it's convenience. Doesn't really capture what's need to be captured. All right, 25. After a hurricane, a disaster area is divided into 200 equal grids. 30 of the grids are selected, and every occupied household in the grid is interviewed to help focus relief efforts on what residents require the most. All right, let's think about that. Simple random means that the subjects are divided and then looking at as an individual. So nothing individual was taken. as a person, like one group, one house. One house would be the simple random. Stratified, this was divided into groups. 30 of the grids are selected in every household. So even though 30 grids were selected out of the 200, what did they do with it? Did they take the whole entire grid or did they take a few of the houses? They took the whole thing, right? So that's actually cluster. Cluster because they took the whole thing. 30 grids were selected as a sample, but then what did they do with the sample? Did they take one or did they take many? That's the thing with cluster and stratified. What did they actually take from that sample? Did they choose a sample from the sample or did they choose the whole sample? This they chose every household. So a sample from a sample is stratified. I just came up with it. A sample from a sample is stratified. So this was a sample, but they didn't take a sample, they took all. So that's cluster. All right. Every 10th person entering a mall is asked to name his or her favorite store. This one's kind of obvious. Systematic. Trying to get through this video. So notice it is super duper long. um, 27. Soybeans are planted on a 48-acre field. The field is divided into 1-acre subplots. A sample is taken from each subplot to estimate the harvest. Here we go. It was divided into 48 acres. The field is 48 acres divided into 1 acre. So we took a sample from each acre. A sample from each acre. So 48 acres was divided into 1 acre. So 48 divided into 1 acre. And then one sample was taken from each acre, each subplot. So this was every subplot, every household was taken. This, a sample was taken from each. So a sample from a sample. This made it stratified. Okay. In 28, we'll look at 28 and the bias for this. So making calls to randomly generated telephone numbers, 1,012 respondents are asked if they rent or own their residences. I think we only have one left, right? So by making phone calls, they made phone calls to 1,012 respondents. So this is simple random. Okay, so the calls were generated by telephone. We took this many as our sample. So that means those people weren't chosen randomly and then just by themselves. They were chosen in a group. And then asked if they own their residence or they rent. Okay. So random would have been them just making one phone call and that's it. But they were actually sampled. They were put in a sample group. What would be the bias for this last one? What if people change their phone numbers? What if people, what if they don't have their phone numbers? Meaning if they got them from one place, they may be missing some people who don't have, who have old phone numbers. Maybe a certain group has old phone numbers. maybe the 1,012 that they choose, maybe 500 of them, no one's answering their phone. As far as, they don't have that number anymore. All right. So those are different types of bias. All right. So all problems and images are taken from Elementary Statistics, Picturing the World by Larson Farber.